Sumit ji, good morning.
Good morning, sir. Good morning.
Neeraj sir, very good morning to you. And
very good morning.
I want to wish good morning to all the
Please.
members, Jyoti ma'am, and everyone here. Thanks for having me for this seminar, and I'm really interested to interact with the students and share my learnings over the years of experience what I have gained.
Thank you, Sumit ji. You have accepted our request and you have given the precious time to our students. And we are so happy to see you for a long time.
Yes, sir. I'm also very happy and very excited to interact with the faculty. And yesterday I saw in the invite lot of faculty members are also joining. So, that really excited me.
And any memory regarding the KIT in your mind?
Yes, sir, definitely. Memory is always continuously there in our mind, although we are working in the industry. But, the alma mater always remains in the back of the mind.
Exactly. And the student is so excited actually. Yeah, please.
Okay, so let's start the presentation. And I hope the students are all joined.
Actually,
Sumit, I want Ariman, our student, to officially welcome you all in this webinar. So Ariman, please take over the session and invite Mr. Sumit sir for this. Ariman?
Yes, sir.
Okay, start the session.
Okay, thank you, sir. Good morning to all of you. Today, on behalf of Electrical and Electronics Department, KIET Group of Institutions, I welcome our guest speaker, Mr. Sumit Pal Singh, sir, our Head of Department, Dr. Neeraj Kumar Gupta, sir, our Additional Head of Department, Dr. Arvind Kumar Sharma, sir, all esteemed faculty members, and our dear audience. I thank you all for joining us today amidst this crisis. This shows your dedication towards creating a better future. We at KIET believe in quality learning and impart the best of knowledge to our students to help them in their professional endeavors. Electrical and Electronics Department is dedicated to achieve excellence in imparting education in the field of electrical and electronics engineering by creating competent professionals and ethical human beings for industry and socio-economic development to meet national and international demands. With this desire to work for the betterment of our students, we have come up with this series to facilitate them with interaction with the industry person and alumni, as this will help them to have an industrial exposure and make them ready to face the industrial demand. We are also trying to foster a mentor-mentee relation to form a strong foundation of technical learning. Today with us, we have Mr. Sumit Pal Singh, Senior Software Developer at SHL. He will be addressing the topic cloud computing, its application, and career in it. Now, I would like to request Dr. Faisal Jalil, sir, to please continue.
Thank you, Mr. Sumit Pal Singh, sir, for giving us your valuable time during this crisis and joining us today. I strongly feel that this event will be beneficial for our students so they can gather as much information and they will clear their doubts regarding cloud computing. I hope this session will inspire our students to join cloud computing as their future career. I request all the attendees to take active part in this webinar. Without taking much time, now I would like to request our HOD sir, Dr. Neeraj Gupta, to welcome our guest speaker, Mr. Sumit Pal sir.
Good morning, everyone. Yeah, thank you, Faisal ji. Again, good morning, everyone, and welcome in this session. I am pleased to announce that Mr. Sumit Pal Singh, Lead Software Engineer SHL, have with us. And today, he is going to deliver a lecture on the cloud computing, its application and career in it. Students, your active participation is important throughout the session. Right now, I have everyone on mute to avoid background noises that may distract you from listening to the lecture. Throughout the session, Mr. Aryan Sahu will managing the lecture. And last, we would like to encourage you to share this lecture with your social network. Aryan Sahu, please. Welcome to our distinguished speaker.
Okay, sir. So I'll take over now, and I will thanks Ariman and thanks Faisal sir for your welcome. Throughout the course of this lecture, if you want to stop me or ask any question, please feel free to use the chat window. Write your question, and I will try to take it up during the session so that it becomes a more interactive session instead of a one-on-one delivery. Okay. So, starting the session, Ariman, can you please confirm that you are able to view the presentation?
Yes, sir. Your presentation is visible.
Okay. Okay. So this session I have chosen to deliver on cloud computing. I hope if the students are aware of the current technology orientation towards cloud, you'll recognize that the world is slowly and steadily, in fact, not even slowly and steadily, it is briskly moving towards cloud. Earlier, when someone intended to host a web application, they used to set it up on their premise. They used to set up the servers on their premise, and then they should have all the networking in place, and then that application would serve to traffic all over the world from their premise. But it has its own challenges, and slowly and steadily cloud computing has come into picture where they are where people are moving their applications to clouds instead of hosting on their premise. So let's start this presentation. So first of all, we'll talk about what is cloud. What is cloud? What is cloud computing? So I'd like to ask the students. They might have some time or the other got a chance to visit a data center. So I'd like to ask the students, how many of the students have ever seen or got a chance to visit a data center? It looks something like this. There are huge racks. There are big servers in place. There is the proper air conditioning. You can't go with your shoes on. And these kind of big data centers are built in place to keep your data secure, to host your applications. And so I'd like to ask, as I asked before, can any of the students, Ariman and other students, can respond? Have they ever got a chance to visit a data center or seen a data center? Can any of the students please respond? Okay, so any which ways, if you ever get to visit a telephone exchange in your local city, you can definitely say there is a data center there. Yeah, see, one of the students, Aryaman, said BSNL. So if you ever get a chance to visit the telephone exchange, there will be a local data center there in place. So for every government organization or every big organization, they have their data center where they manage their data and they manage their services, which are their web applications. But now with cloud coming in picture, as shown in this diagram, clouds are basically a replacement of the data centers. You don't build your own data center. You rent out the infinitely big data centers provided by big players. So coming to a formal definition of cloud, it is basically a combination of hardware and software services which are delivered to you as a network service. So you can enormous quantity, enormous big size of servers, data storage, all these facilities are delivered to you through internet at your home. So basically, you eventually go to rent out these big servers, and you can rent out according to your capacity, according to your usage, and it's and you just need to pay for the amount of storage that you have used, amount of traffic that you have handled. This way it goes round. And basically, the motivation of cloud computing coming into picture, and the reason for its growing demand is because basically it is a replacement of a data center. So let's come to the next slide, where we talk about why do we need to, or why any software service provider needs to shift to cloud. What is the motivation? What is the reason? What are the advantages for it? So see, first of all, if when moving to cloud, it helps us in reducing our business operation cost. If you have to manage a data center at your own premise, there is a lot of expenses. You have to set up the data center, you have to set up the servers, you have to manage you have to keep the staff, you have to make sure that there is a continuous power supply, there is a no power outage. If there is a power outage, your online services, your website will stop. There is an operational cost, there is a maintenance cost. So it is a very expensive affair. And for someone who has a small business which is trying to take it to online, this much amount of investment doesn't justify for the small amount of profit which he intends to make. Then the second, apart from cost, there is a second advantage, is just flexibility. You always don't need to be present at your data center, so that you can manage it. You can manage your applications, your service sitting at your home, because it is remotely available. Now, scalability is one of the another big advantage here. So clouds offer automatic upscaling and downscaling. When I say automatic upscaling and downscaling, for example, most of the students would be able to connect with popular shopping websites like Amazon, Flipkart. So if you must be knowing some days there are sale days. There is a big billion day sale going on, and on those days suddenly the traffic rises many times, 10 times, 20 times. So if you are having 1,000 requests, 1,000 visitors per minute, let's say, it would be in the sale days, it will be 10,000, 20,000 visitors. So how will you manage this? What is the scenario? Will you set up your infrastructure according to 20,000 customers throughout the year? Is it justifiable? To mitigate this situation, clouds offer automatic upscaling and downscaling. Whenever the traffic or the number of requests per minute exceeds a certain threshold, they will automatically upscale your server. So they will increase the resources on your server. They will increase the RAM, they will increase the storage, they will increase the network bandwidth, so that you are able to handle the increased traffic of customers. And when your sale is off, it can also reduce or downsize your infrastructure. So this way, this process is called automatic upscaling and downscaling. So this way you are able to meet the sudden spike in traffic increase. So this is a wonderful facility which the clouds provide. And then you just have to pay for the increased capacity only for the time that you have used it. Otherwise, if it was your own data center and you set up the servers according to the increased traffic, then you have to maintain it throughout the year. Its maintenance cost you have to pay throughout the year, but not in the case of clouds. Only for the time that you have used the increased traffic, you have to pay for it. And another challenge when setting up your own data center is that you also need to set up a duplicate data center, which is called disaster recovery, which means that if due to a sudden power outage, your data center is down, you can't keep your online business down for that time. So you need to have a duplicate data centers at some other place, which will serve as a backup data center to this one. So this is again a 2 times cost. So this kind of disaster recovery, you do not need to take care when you are hosting your applications on the cloud, because cloud manages it on its own end, and they'll not charge you for this. It is their responsibility to give you a 99.9% uptime. So it will be very, very rarest of rare situations that your application might go down, or even if it goes down after a few seconds, it will cloud providers will make sure that and there is a contract to this for the minimum uptime requirements. So like they have to meet to this is called service level agreement in software terms. So the cloud providers have to meet this service level agreement. And low latency, one of the challenge in web when you are hosting web application is latency. If you have set up your data center in, you say, Delhi, and someone is trying to access your application from US, there will be a certain latency in place, as compared to if someone is trying to access it from Delhi or Mumbai or Kolkata. The latency will be lesser as compared to if he's trying to access it from America. So how do clouds offer low latency? They provide location specific cachings. So some of the part of your applications which is not frequently changing, like the pictures, the videos, these things are not frequently changing. These kind of data they will keep in the location specific servers, so that they can be downloaded faster at those locations. So because of these, there are other advantages as well, but these major advantages, the inclination towards IT service providers is to move to cloud. So I like to introduce who are the major key players here. The major players, the biggest, I would say, biggest market share holder currently is Amazon. Amazon, my student definitely must be knowing Amazon shopping portal. But another big part of their business is Amazon Web Services, where they provide you cloud infrastructure through which you can deploy your web applications on cloud. And there are other apart from web, there are other services as well. Now the second key player is Microsoft. After it has acquired Azure Cloud is now a part of Microsoft. It is market share is lesser as compared to Amazon, but the popularity is slowly and steadily growing at a brisk pace. So they are also, every big company like IBM, Google, everyone is fighting for a larger market share in the cloud domain. And Google has also built its wonderful platform of services, and they are trying to compete. But currently the market share is less as compared to Amazon, but they are trying their best. They are offering services they are giving discounts as well. So the fight is there to be the dominant in the cloud domain. So IBM, Salesforce, these are other key players in this domain. So I like to take a pause, and I like to ask the students, Aryaman and other students, if they want to ask. There is a question from Aryaman: the data transfer to cloud is real time or scheduled transfer? See, if you have hosted your web application on cloud, it is real time. It is not scheduled. In fact, you try to access Amazon.com shopping portal, it is a real time data transfer. But when you are trying to upload your application first time on the cloud, you have written the code, you have tested it locally, and you are trying to deploy it first time on the cloud, that is not real time. You have to upload your code into the cloud environment. It will take some time to initialize, and after it has initialized, it will give you a green signal. It means that now your server is up and running, and then there is nothing as delay or lag. It is always real time. Another question has come from Prakhar: low latency available in mobile also? See, Prakhar, cloud or any server doesn't discriminate whether you are accessing it from a laptop or a cloud, or from a laptop or a mobile or a tablet. It doesn't discriminate. So whatever will be the latency, it will be same for mobile, same for laptop, same for smart TV, same for any device. So any more questions from the students? So see, if they Prakhar has asked regarding during traveling. So if you take an example of any navigation app like Google Maps or any other navigation apps like Uber, so all these applications deployed on your phone are trying to communicate with any of the service generally deployed on cloud. So if you can see, after a couple of meter move, the icon moves on the map. So it is always the real time data transfer happening. Sona Singh is asking cloud strategy. So it is a big question. You need to elaborate what do you mean by cloud strategy. Otherwise, it won't be able to answer this question directly. Okay, I'll move to the further slides and we can take the question later. And Sona Singh, if you can elaborate on your question, then we'll try to answer it in more detail. Okay. So I hope the students you must have got an idea of cloud. What is cloud? So I'll try to move ahead in this understanding and try to demonstrate you the types of clouds available. So see, we can categorize clouds based on various parameters. So one of the parameters for classifying clouds is based on accessibility. So there are public clouds in which all the services and all the infrastructures are shared by various clients. For example, Amazon has a public cloud, and there are many different companies who are deploying their web application on cloud. So basically, they're sharing the infrastructure and services which Amazon is providing. So in case of public cloud, all the infrastructure and services are in the control of the cloud provider. Now there is a private cloud. If you feel that my data is very business critical, I don't want to share my data with everyone. So you can deploy some firewalls, and if you say that I want to only share my application within my company for the internal use of my employees. So you can deploy a firewall. Firewall is a security tool. So a private cloud sits behind a firewall, and in that it has a very restrictive access. Only few people from accessing from a particular network can only access the application. And in this case, there is you can also say that since my data is very critical, I don't want to share my infrastructure or my server with anyone. So in this case, the cloud provider will create a separate server for you, and it will not in any way be linked with other servers. So the risk of data sharing or data getting accessed by unauthorized persons be there. So there will be no infrastructure sharing between the applications happening or between the clients happening. And then there is a third, which is a hybrid kind of approach. In this, you try to create a front-facing application which is deployed on a public cloud, and everyone and its scope is bigger and everyone is able to access it. And you try to deploy your business critical application or your application owning the critical data into a private cloud, and and then the public cloud in turn accesses the private cloud and shares the data. So basically you try to leverage both the features of scalability of a public cloud and security of a private cloud. So this was when you are trying to classify your clouds based on accessibility. You can also classify your clouds based on type of the services. So coming to this slide, if the first and the basic vanilla version of cloud services is infrastructure as a service, it is also called IaaS. So it is the most basic category. In this case, you're simply renting out the servers and the virtual machines from the cloud provider, and the cloud provider is managing the infrastructure, everything, and you are basically, it is most simplest form of servers for rent. So you are renting out the servers, you are deploying your software on them, and you are making use of it, and you are paying as per your usage, as per your traffic usage, as per the amount of database that you have used. So you are paying as per your usage. So again, Amazon and Google Cloud Engine are the key main providers for this. Now comes a more sophisticated, or you can say built on top of IaaS is PaaS, platform as a service. In this case, the cloud provider also provides you the platform on which your applications will run. When you are using IaaS, you have to set up the platform yourself. You have to do all the runtime environments, operating system, all these things you have to set up yourself. But in case of PaaS, these things are already set up by the cloud provider, and you just need to deploy your application on it. So as the slide said, it utilizes the basic infrastructure of IaaS, but includes on the top a couple of things like operating system, some development tools, some middleware it will include. So that for the user, it is for easier, the deployment faster, and setting up the environment is easier. So more of a plug and play kind of approach, trying to make it a more easier to use for the client's approach. So again, AWS offers Beanstalk, which is a very simplified service in which you can deploy your web application in 5 to 10 minutes. Again, Google, always in competition with AWS, has also bring up an app engine. You can do the same use case here as well. Now the third kind of categorization, which is SaaS, software as a service. Again, it is built upon on PaaS. So IaaS is built on, so PaaS is built on IaaS, and SaaS is built on PaaS. So first we took the hardware, and we configured our IaaS, and we started renting out to our clients. Then what we thought, how do we make it better for the clients? So we installed the operating systems, we installed the environments, we installed the development tool, and we made it as a platform as a service. And then we started renting out to clients. Now we again thought that how do we make it even more better for our clients? So that way SaaS came into picture. In this, the software is already ready to be used by the clients. You just need to subscribe, and then you can start using it. So for one of the easiest example, I would say, is Netflix. Many of the students would be aware of Netflix. You can simply pay a subscription fee and start watching their movies. So what are you doing here? You are simply renting out their services, in which which includes their IaaS, means their servers, you are accessing their servers. Their PaaS means their environment on which this video streaming application is running, and their services, which is video streaming. So you are basically paying for all the three layers in the form of a subscription fee, and then you are able to access the videos or the movies. Again, another example is Google Drive. You can upload your notes, college notes, anything, PDF files onto Google Drive. It gives you 15 GB free space. As soon as you move from 15 GB to your usage exceeds more than 15 GB, you need to pay for the fees. So again, Google has built up a platform for data, for storing files, and it is renting out it to you. So this is an example of a SaaS service. A more relatable example is this Google Meet, which we are using to conduct our college video seminar. Again, this Google Meet is a perfect example of SaaS, software offered as a service. So we might be under the free tier, but when companies use it, then Google charges for them, and then they provide some additional facility as well as to record a session and other different kind of facilities. So that was SaaS. Now the latest and a new thing is coming into the market, which is function as a service. It is currently not much popular, but in this, you don't write a complete big piece of software and then try to rent it. You try to write a small utility kind of software, and which anyone can use. Anyone can integrate their software with your independent function. One of the good example I would say for this is stock prices. If you have written a function which is providing the current latest stock price of a stock, and then can be 1,000 websites showing this price on their website by simply integrating with this function. Another can be currency converter. What is the value of dollars in rupees today might change in a couple of minutes tomorrow, a couple of minutes now, or can fluctuate throughout the day. So you can integrate with such a function which is providing you the latest currency conversions, and you can display wherever you want in your website or wherever you require it. So this kind of ready to use functions are called functions as a service, which you can deploy. It is again another abstraction over the SaaS offering, and basically a small reusable kind of functionality you can put in a FaaS. So I like to take a pause, just this descriptive. Again, as I explained, first of all, when cloud computing came into picture, there used to be IaaS. Then in this, basically, cloud providers were giving you storage, runtime environments, and networking. Then the offerings evolved, and then there came PaaS offering, in which they were also configuring the environment platform. Like, I want my application to run on Windows server, or I want it to run on a Linux server. So, and what all the things my application requires. It requires a Java runtime environment, or it requires a .NET runtime environment. All these things they were trying to already pre-configure and give it to you, so that it is easier to use for you. And then again came software as a service. They also started deploying their softwares and then offering to you on a subscription basis, so that you can use them and pay subscribe on a monthly rental basis. So I like to take a pause after the slide, and again I like to take up. There are a lot of questions coming. Let's see. So Vaishnavi Singh is asking, can we access private cloud computing of any organization? Because it is a private cloud, it will not be easily available to you to access it, because I have explicitly paid for a private cloud, which means that I'm very critical of my data. I don't want to share it with any unauthorized user. So there is an additional level of security available, and I'll make sure that only from my company network my data can be accessed. So it will not be easy to access any private cloud outside of its network. So any of the any more questions on this different type of classifications of cloud? Students, please feel free to ask. Okay, so Aryaman is asking, with these services shared by many users, is there a chance of data theft? So see, even if you are going for a public cloud, there are some kind of authorization, and there are some kinds of security in place. So answering to your first question, for example, if you log into your Google account from any different computer which you have not logged in before, it will send a notification to your phone. When you will tap yes on it, then it will log in. Similar is for cloud. they are providing some basic security to you, basic authorization and data security to you. And it's not like it's very easy to hack the data, to steal the data, or data loss. And cloud providers, and especially big providers like Amazon, AWS, Google, they are making sure that their offering is very secure, so that they are able to build customer trust, and people are able to trust them more and more. So they are working big time on it. They have invested lots of it, and it's pretty secure, because many big companies are slowly moving their offerings to cloud. Okay. And answering to your second part, data leakage. See, some data, for example, Indian government have their Aadhaar card data. Now this is a very critical data with respect to national security. So I don't think, or it is generally not advisable to move such kind of data to cloud. Okay, where cases of national security come in. So they maintain their own premise, they maintain their own data centers, their own servers. So there is a use case for everything. So this kind of security related data is generally, currently companies are not preferring to move to cloud. They're preferring to move to cloud those data which is not very critical to maybe security, or very, like banks are not moving their data to clouds, because it involves, directly involves money of clients, customer trust. These kind of concerns are there. So it is a choice, it is a trade-off between the two things, which any company has to make. So there are a couple of more questions. So Rajat Shrivastava is asking, which cloud migration of which organization is better? See, currently I would say that the best provider is AWS, Amazon Web Service. And but Azure Cloud is also slowly coming up with their offerings. Their their charges are a bit on the higher side, so that but their billing strategy is also different. If you register to Amazon, they give you their services free for 1 year. Okay, and after 1 year they start charging you, and that too on usage basis. So currently I would say that Amazon is the strongest player going in this domain. Google are also coming up. They are they have built wonderful services, but in terms of marketing and customer trust, Amazon is leading in this domain. Okay. So I like to move to the next slide. There's okay, I'd like to move to the next slide. This is a more technical, or you can say a more detailed kind of demonstration of types of cloud infrastructures. So a couple of students might find it difficult to understand. If they do feel free to stop me, and feel free to stop me and clarify your doubts. So as I explained you earlier we tried to classify clouds as public, private, hybrid, then as IaaS, PaaS, SaaS. Now we'll take a bit more detailed deep dive into trying to understand how the infrastructure is set up in different ways. So the first initial way of cloud offering was a hypervisor based approach. If you see on the diagram on the right side, if for providing my services as a cloud, I would generally procure a big servers. On a big server, I will install an operating system. On an operating system, I'll try to install a hypervisor. A hypervisor can be a software as well and can be a hardware as well. What this hypervisor will do, this will try to break this big server into small different servers, and then I can rent each of these small servers to my clients, and then my clients will again install their operating systems, and then their applications and whatever their application additional libraries which their application needs, and then my clients can use my offering, my cloud offering in this way. So it can be a hardware, it can be a software as well. But see, the big challenge in this approach is when I procure my big server, I install operating cost for it. So I pay the licensing fees of the operating system. When my clients take a part of this divided server for their own use, they again install our operating system on it. So they are again paying for the licensing cost for that operating system. So this was the biggest challenge in this approach. Although it is still, this approach is still pretty much in use, but this challenge motivated the requirement of a different approach, and then came a container based approach. What happens in this container based approach is the cloud provider rents out a big server and installs our operating system on it. And in this operating system, the cloud provider installs a container engine. Here I have taken an example of Docker. What is Docker? Docker is basically a virtualization tool or a container. So the cloud provider installs a Docker engine on their operating system, and he then offers his services to the clients. Now clients come up with their Docker images, and they simply install their images on this engine, and they are able to use the hardware and all the facilities of the big server in a shared way. So in this diagram, you can see there are two applications running. Both have been deployed using a Docker image on the Docker engine, and so basically this kind of approach is called a container based approach. It is like a standardization of their application and their dependencies. So if I have this app, I know what all dependencies or what all libraries my app requires. So it is, I say my app requires Java running version 8 and requires a Linux operating system. So I will specify all these things in a Docker file, and using this Docker file, I'll build my Docker image. And once my image is ready, I can run it on any engine, on any cloud. It is like a portable device. The popularity why this approach became so popular was that it is a portable device. Once you have created a Docker image, it contains everything that your application requires, and you can install this image, mount this image on any engine and run it. So that is mentioned in the definition as well. It is a packaging of the application and all the requirements like runtime, tools, libraries. And again, as compared to the previous approach, here I'm only paying the licensing fees of one operating system. So it is saving licensing fees of which we multiple operating systems which we are paying earlier. And because of this, we are able to utilize the hardware better. Any app which has is currently facing a lot of traffic, and another app is facing a lesser traffic, so because it is a shared hardware between two, better utilization will be there, as compared to you fixed some amount of space for one application, some amount for another. So it is a fixed space. In this case, both the applications will able to use only that fixed space. But here it is a more dynamic kind of distribution. So in this case, the hardware utilization is better. And one of the another big advantage is that the hardware is abstracted from the team which is developing the software. So you don't need to worry where my application will deploy, how will they manage its life cycle, how will they do the maintenance, because you have specified everything in your Docker image. So your Docker file will run on the Docker engine, and you don't need to worry about any of the hardware details. This concept is called abstraction, where you hide unnecessary details. You don't show the details which are not required to show to a client. So in this case, in this approach, the hardware is abstracted. You just need to mount your image and install it. And the last one is, like I mentioned earlier also, a serverless approach. It is similar to the function as service which I talked before. In this case, even we try to abstract the environment as well. We take everything from the cloud provider and we write our small logic in the function offering given by the provider. It is simply a kind of request and response model. You send a request, you receive a response. If you send a particular request n number of times, and if it's a non-changing value, you will receive the same response n number of times. So basically, the examples which I told, like currency converter and stock prices, kind of a reusable kind of a code, you try to use a serverless approach in this case. So basically, it discourages the coupling of environment with your application, and it provides a platform for you to develop your functions and then use the cloud capabilities like storage, networking, etc. And behind the scene, the allocation of machine, allocation of RAM, allocation of computing capacity to these functions is decided by the cloud provider. If it is receiving more traffic, they will try to allocate more memory to it, and if it is receiving lesser traffic, they will try to reduce the memory to it, which is also beneficial for the clients. They are also paying according to the capacity which is getting used, they are using. But this approach currently is in a very nascent state or a developing state. Not many companies have moved to this approach. It is a developing phase. So it is suitable for designing small applications, like I gave an example of a currency converter or a stock prices, these kind of things. And another challenge in this approach is that you cannot have one of your function deployed on Amazon and integrating with another function deployed on Google Cloud. So you need to have all your functions in Amazon only, so that they can communicate with each other, or they can for example, a function deployed on Amazon is integrating with the database also present on Amazon. It can't be like a function deployed on Amazon is fetching data from a database deployed on Google Cloud. That this kind of integration is currently not possible, and since it's a growing approach, there are no standards in place right now. When we work in software, there are various standards which we try to follow. There is a REST standard, there is a HTTP standards, and there are other n number of standards according to which we try to build our software or write things. So in this serverless approach, currently standards are developing, not very much established right now. So the example of this serverless offerings are Google Cloud Function, AWS Lambda. It is currently gaining popularity. It's in fact it's significantly popular right now. And then there is IBM, Azure, and other cloud providers as well. So any questions from the students on this infrastructure approach? So Priyanka Yadav asked regarding scalability and elasticity. See, scalability is a factor which is derived by traffic. The traffic is the driving factor for scalability, and elasticity is driven by computing complexity. If you are having very complex calculations and you need to do lot of correlation with data, do some very complex calculations. So your server requires more and more capacity to do that. So there is it is where elasticity comes into picture. So Ariman and other students, were you able to get a grasp of this infrastructure approach?
Yes, sir, we could understand the basics, like as you explained, but I think we need to research some more on these topics to get a good knowledge on these.
Yeah, I understand. But I like to say to the student that cloud is right now dominating the information technology market and the software market, and there is huge scope, and the requirements and the market will continue to grow for years now. And might even come a time that on-premise servers would completely go away and everything would move to cloud. So there is a huge scope in this field, and if you try to take interest, it is a very very interesting field as well. So for the purpose of demo, I also created a sample application so that I can demonstrate to the students. Okay, so what I did was I I used a Java environment to write a simple notes application. It's a very simple application. It only has three classes, and what it does is that it manages your notes. If you want an online space to manage your notes, you must be having many notes application in Android as well. So what are they doing? They are storing your notes on the server, and whenever you're trying to fetch your notes, they are giving you your notes. So I'll try to demonstrate this software in a couple of minutes to you. So I will simply start my server on my local computer. What it will do is that it will start a new server for me. I just need to wait a couple of minutes for it to start running. Okay, so it gave me first, when I try to run my code, it will first compile the code. So it gave me that compilation has completed. Now we just need to wait a couple of minutes when the server initializes. As you can see here, it is using Java version 8 to run your server, and then Spring means it is a Java-based framework for building web applications. So as I clicked on launch, it will start a server for me. So these are the startup logs which are printing, and it has finally told me that it took 19 seconds to launch my server. Now my server has launched, and what my server does is that it has two features. It I'm able to save my notes and I'm able to read my notes. So when I call the get URL of this server, as you can see, this is localhost. Localhost means there is a server running on my computer, and I can only run this server from this computer. So that is why generally we type facebook.com, google.com on the browser. But since it is localhost, I'm able to run this application here. So I called get notes on my server. So it is telling me welcome to the notes app. Right now I don't have any notes. What I will do is now I'll try to add a note. So I'm calling add note, and I'm passing this expression first note. For example, I say welcome to all the students. So it assigned it a unique ID, and it told me that note number 2 is added. Now I added two notes here, my first note and my welcome message. Now I try to read my notes. So you can see that all my notes are saved in the server. First note, welcome to all my students. So I can read my notes. Now it is a very simple application. You would say a vanilla application, but I built it because I want to demonstrate an important principle of accessibility, of easy accessibility of deployment using cloud. So now, since I've made this, I've built my note application, which can get notes and add notes. I'll try to deploy it. I'll try to deploy it on cloud. So how will I try to deploy it on cloud? I will go to, let me start afresh. So I'll go to aws.amazon.com. So for deploying a simple web application, there are different services. I'll try to show the services as well to the students. So I'll go to my account. And while it's loading, I'll like to say to the students that do explore these kind of cloud providers like Amazon Cloud, Google Cloud. Register yourself. They will ask you for your debit card, but generally it is free for 1 year. So be careful of utilizing the resources, but do try to get your hands on these things. Get your hand dirty. Try to play with these services. So when you log into Amazon, AWS Amazon, it will show you what all services it offers you. So this EC2 is an example of the container managed services which I mentioned, and there are other services like, I would say one of the common storage is S3, which is again a bucket storage service. You can store your data in the form of buckets here. And there is RDS, means you can like the databases which are there. If you want to upload manage your data on the cloud, you can use RDS. And there are numerous services available here. IAM is identity access management. It is used for security and authorization, authentication, these kind of things. And there are numerous services, and they are continually adding new and new service. There is Alexa service. Alexa is basically a device in which you can access the internet using voice commands. So you voice in your command to the Alexa will translate it into a text message and send it to, integrate it with a service deployed on AWS, and from that service it will fetch the response back and show it to you, and again voice out that response to you. So you say, Alexa, play a song, and it will take this request to the server, search for a song, and then play that song using online streaming. So coming back to the Notes app, for that case we use Beanstalk, which is a service for simply installing a web application, which I showed you already running on localhost. So just for saving time, I have already deployed this service using Beanstalk, and I configured a Notes app, and I simply uploaded my web application zip file on this Beanstalk, and then I can, whatever I was able to do there using on this website, using local host. In this case, since it's local host, the server is my computer. But in this case, since it's deployed on AWS, the server is Amazon. So here also, I can access the same Notes app, which I deployed just before this session, and it only took me 5 minutes to deploy. So here also we can call get notes, and I'll try to add a note to this, add note, and I will say welcome KIET. Okay. So note number 1 added, and then I try to refresh this link. This note is
Sumit sir, there are few questions in the chat box.
Okay. I'll try to go through them. So I hope you must have get an idea of the flexibility and ease of deployment which comes in handy with cloud. I'll share this URL with you, and if you'd like, you can play with the service for a couple of I would say half hour or 30 minutes, and then I'll terminate this server to avoid getting big bills. But you can access these services using your mobile as well. So that my intention of doing it was to demonstrate how easy it is to create an application and deploy on cloud. Okay, so let me see the questions. I think I answered Priyanka's question. After that, cloud bursting. See, cloud bursting is not specifically related to cloud computing. Okay, it is a different principle and doesn't directly relate with cloud computing. And again, fog computing, see, there are different terms, there are different terminologies coming up in the market every day. Okay, so these kind of terminologies are not directly or widely used in the cloud infrastructure or cloud domain. So there are many terminologies which come up every day, and people start using it, but the ones which are generally popular are the ones which we talk about. So any more questions the students are having?
Thank you, sir. Very good session you have taken, and knowledge gaining of our students. Aryaman, vote of thanks, please.
Now I request Sona Singh for the vote of thanks. Sona.
Okay. Sona, please. Vote of thanks.
Sona Singh.
So I can see Jyoti ma'am's message here. Yeah, I like to thank.
Hello.
Yes.
Sorry for the disturbance. So my mic was not working.
Okay.
So as we can see that this webinar is coming to the end. So according to Saint Ambrose, no duty is more urgent than that of returning thanks. So I'm delighted to have been given the pleasant duty of delivering the vote of thanks this afternoon. I would like to express my gratitude to our chief guest, Mr. Sumit Pal Singh, sir, as no program can become successful with a single person. So I extend my big thanks to our department, Electrical and Electronics, our HOD, Dr. Neeraj Kumar Gupta, sir, additional HOD, Dr. Arvind Kumar Sharma, sir, the coordinator of Alumni Interaction, Professor Jyoti Srivastava, ma'am. So, we are really enlightened with your knowledge and experience. I personally liked how you highlighted the topic, cloud computing, its application and career in it. We appreciate your efforts for taking out time from your busiest schedule to grace the occasion. observed you have inspired, motivated, and installed us all. I believe that many of my fellow audience have gained lot of information and cleared all their doubts regarding this topic and will surely look up in future to take cloud computing as a career. Our heartfelt thanks to the audience for active participation in this webinar. With these warm words and a kind message, we move to the end of today's webinar. Thank you.
Okay, thanks a lot, Sona. And I'd like to thank Jyoti ma'am and Neeraj sir, especially for having me for this session. And also Blandina ma'am, nice to hear from you after such a long time. Also Arvind sir, nice to see you, sir. And Rahat sir, again, nice to see you, sir, as well. And I like to share one last thing with the students related to cloud computing. I have started a YouTube channel, and I would like to encourage students to visit this channel. And currently there are just I was able to create 3 videos, and I'll be creating some more videos as and when I get time. But I would like to invite students to follow this channel. And here you can uh, get notifications for my new videos, and you can uh, subscribe to my video feed. And there are a couple of videos. Currently there are 3 videos in there. So the first video is again an introduction to cloud computing. The second video is around event-driven programming and actor-based concurrency. It is more of more inclined towards building applications using computing and parallel processing kind of stuff. But again, if you will go through this, you will definitely get an overview of how things are done in the software development domain. And again, third video is around command query responsibility separation. It is a design pattern. So whenever we write software, we follow a particular design pattern. So it is a new upcoming pattern which is very gaining traction in the software development domain. So kindly do watch these videos and subscribe to my channel. And also you may post in the comments what kind of videos you would like to see more, and I'll try to create videos around those topics. So I'm sharing
Fantastic.
the link of
Fantastic, Sumit.
Yeah.
Kindly send the link to me and some of the text line for the students, and I'll definitely forward it to all the students, and maybe you'll be receive some of the message from the students in the coming week.
Great. That will be great. Yeah, I look forward to comments from everyone, including faculty and students. So I'm sharing the link here in the chat.
Please.
Kindly do subscribe and watch the videos. And yeah, it was really very nice connecting to my alma mater after around 10 years, sir, now. But it feels just like yesterday. So it's feeling very nice, feeling very happy right now.
Thank you so much.
Okay, sir. Nice to see you, everyone. Goodbye, students as well, and faculty. And Fazal sir, thanks to you as well for organizing this.
Thank you.
So I'll
in the
take
coming
leave now.
week, Sumiti, in the coming week, we'll be organized one of the meeting with some of the students too. Only some of the students who want to work in cloud computing. After seeing all the videos and give the some.
Yeah, definitely, sir. I'll be happy to.
Thank you.
Okay, sir. Bye.
Bye. Thank you all participants. Thank you.
Now go to the
Thank you, sir. Thank you, Sharma sir.
Now all of us go to the second lecture. After 10 minutes, we'll be meet again.